Alright, so it's time to take care about the autopsy. What we have to, what we deal here with is a Invensys pump, 65 watts. The one that went into the coffee machine is about 55, so it's not so strong as this one, but it does the job. And yeah, there are some other data, it's like you can run it for a minute, not for another minute, and with different voltages it looks differently. It gets pretty warm after a while, so that's the reason, and the coil can be burned. I have no idea what's the construction of it. As you can see, it looks like it is not serviceable, which is, there is nothing that is not serviceable. Everything is serviceable. And I will knock out those hooks over here, and we will try to see what's inside, because I have no idea. Okay, so this is, I basically just bent them in, and now we should be able to take them out and off. So okay, this is interesting. Why would you ever service a coil in this case? Just as I thought, the coil is inside. This could be used as a good magnetizer. We'll see. And this one, it also looks like a sealed unit, so maybe it's really unserviceable part. The thing. Let's take the angle grinder. Okay, I cut it on one side and I tried to prep it, and it didn't work, so I had to cut on both sides. And now we can actually open this puppy up, and I assume that, yeah, exactly, as you can see, it's a pipe, basically, this element, and the two elements are squished together on a hydraulic press. This is a new old smartphone, salvaged. Okay, I hope it will still be in the video. So what do we have? One spring, one piston, one gasket. What could go wrong? Well, once again, this is the piston. Actually, the piston is only this part over here. This one here, it's just, how I would say it, this is the core. This is the core of the coil, and this is required to put it into movement and into motion, and it has to be quite solid and quite heavy to have enough force to push it. Now it rests inside of this one on this spring, and it's pretty tight, but this here surface doesn't have to have any tightness whatsoever. It's only for motion. The all work is done by pushing this piston through this little hole, and I don't know if you will be able to see inside of it. I will try to focus on this one, but I don't think it will be so easy. There is a little gasket inside, maybe ceramic, maybe rubber, I'm not sure. It's this should keep it tight, but I think it's already, you know, too loosey. So replacing that, very difficult. This spring inside over here, it's a first, let's say, part of the check valve. It basically closes this little hole that goes through the piston, and every time piston pushes it, it makes pressure. And here is another check valve inside of it. This one I cannot take out right now. I don't know, maybe it's screwed, maybe it's glued inside of here. As you can see, this is the way to access it from this side, but this is definitely a check valve, because you can, I don't know, maybe you will hear that. This is pushing one way, this is pushing the other way, so it releases some pressure when I blow into it. I blew into it, you know. Okay, so this is basically the principle of how it operates. And now, as to this ring, as you can see, what's interesting, it's rusted inside, so the pressure inside is enough to go through this one, even though it was pushed against, you know, those two parts was pushed against each other very, very tightly and strongly. So, you know, rubber gasket, this, and then, you know, hydraulic press takes this part in, and the other part of it pushes it down, making this little collar here around it, you know. What's interesting is that this part is also machined. It's not a, let's say, it's not created in a process of you know, pulling or pressing or something like that. This is a part that comes from a machining on a lathe. You can see the marks on both sides of it, so you know it's machined in and out. And this part originally it must go straight, and then when the press comes down, it creates this little I don't know, chamfer you would call it, I guess. Okay, so this is basically how it works. I would really agree, this is not serviceable. You cannot really repair that. I mean, you would really need to have a lot of patience and kind of experience with several of those. And yeah, maybe one more conclusion as to the coil itself. As you can see, there is a number here, 13. I don't know what does it mean in that case. But the thing is that it's only on one side of those connectors. Maybe it's related, maybe it's not. My conclusion is that beyond the coil, maybe there is a diode inside or something like that. I didn't really check. Let's measure that. Okay, let's see. Anything? Nothing. Nothing. Let's say the high resistance. Does it measure? Yeah, let's measure. No. And nothing. You see? It shows nothing. Absolutely nothing. I hope you see that. I'm not really sure. Let's put it like this. This is measuring on 2000K, so it's nothing, and it's nothing. It's supposed to be something, so my probes are not so bad. Let's take it into diode tester, and here we have nothing. The other way, we have a reading. So there is a semiconductor in this coil somewhere, and my conclusion is that no, I don't have conclusion. I don't have conclusion. It's the point is, if you connect it with the wrong polarity and you press it into making coffee, it operates, but it will not pulse it for getting steam. So you need to connect those two in the right way. Total cost of repair in cash, 0. In time, maybe hour and a half. So, was it worth it? Well, it's not a new thing. So, would you do it for your friend? If I spend so much time doing it for my friend and then I just got a coffee, yeah, I would say it is worth it. I was drinking this stuff before and it's not so great until you get this color. So as you can see, this chestnut foam on top of it, this is all you want, this chestnut color foaming. This is something that means you got it right. And again, more videos coming soon.